Okay, so really quick, y equals 3 over x plus 2 plus 4. This is our graph that we want to be able to accomplish. You should be able to leave this class being able to graph anything that you see. Now, this is a review, then we're going to show you some new ones. Somebody, what is the horizontal shift of this graph? Left 2. Up 4. This is x to the first power. So, is the first graph could be on the top or the bottom? Bottom. And then the next one, top. They will be opposite because you have an odd power. That is what we reviewed yesterday at the end of class. This is something we've covered before. Everybody good? All right. Let's try one a little bit more difficult. Y equals 4x minus 3 over x plus 1. Totally different scenario. Why is this different? There's an x on the top and an x on the bottom. We can put it in a form that we could graph if we simply do something, if we divide it. So it's asking to be divided. It says 4x minus 3 divided by x plus 1. If I simply carry that operation out, how many times does x plus 1 go to 4x minus 3? 4 times. I get 4x plus 4. Subtract, and what do I get? Negative 7. So that means I have a remainder of negative 7. So in other words, I've just made this look like 4 minus 7 over what? Do you agree that these are the same? I simply wrote them differently. I'm going to write it differently again. I'm going to write it as negative 7 over x plus 1 plus 4. Does that look more familiar like what we've seen? So simply by doing a division process, I get a function that I know how to graph. I'm going to sketch the graph. What is the horizontal shift? Left 1. Up 4. What? Flip it because you got a negative. Very good. How's that? Okay, y equals 5x over 2x plus 4. Same type of scenario. We don't have another number up there, but we can still divide it. A lot of people shut down if they see a problem like this because you don't come up with integers. How many times does 2x go into 5x? 2.5 times, or 5 halves times. What's 2.5 times 2x? 5x plus, what's 2.5 times 4? 10. Subtract, negative 10. So the function, instead of writing it like that, I could write it as 2.5 minus 10 over 2x plus 4. Or negative 10 over 2x plus 4 plus 2.5. Simply move your addition around because it's commutative. Yes, I'm not going to simplify it in case you would come across one like this. For example, if there was a 9 on the top, then you couldn't simplify it. But can you tell what the horizontal shift is? Why negative 2? That's what you would plug in to solve to get 0, correct? So whatever you would plug in to solve to get 0, that's what the shift is. So 2x plus 4 equals 0, we get negative 2. So as I graph this, our horizontal shift is -2. My vertical shift, 2.5. And what else? Flip it. And you say, oh, big deal. I learned how to divide. What about the next one? What's different about this one? It's an x squared. Okay, so now you have a higher degree polynomial on top, and we haven't talked about that yet. You know, what if you have a higher degree on top? What if you have a higher degree on bottom? Those are things to think about. Okay, now pause and watch this really quick. Do you agree that for most of this graph, it kind of looks like a horizontal line? A horizontal line of +4 most of the time. When we divided it, we came up with +4 and a remainder. This is what it wants to look like. But it blows up at -2 because, you know, you got this undefined piece there. So that's, you know, you have this vertical asymptote, -2, everything blows up. Look at the next one, okay? Would you agree that this wants to look like +4? That's what we divided and got. This was our remainder. It blows up at -1 due to that vertical asymptote. Look at this one here. It wants to look like 2.5. The line y equals 2.5, and then it blows up. So as you look at this one, if we were to divide it, anybody notice what happens when you divide this? Instead of dividing like we did before, I could just factor it. Yeah, it divides evenly. There's no remainder. It wants to look like. It wants to look like the graph y equals x plus 2. What does the graph of y equals x plus 2 look like? That's a line. The other ones were lines too, weren't they? This is just a line that has a slope, correct? Now here's the difference. There's no remainder. There's still a problem. If there's a remainder, you're going to have an asymptote. If there's no remainder, if it divides evenly, there's a gap. Anybody want to guess what the x value is where there's a gap? -1. Why did you get -1? That's where it's undefined. Okay? Now, I'll show you what this is going to look like. Let's get a graph. X plus 2 up 2 units, and then you could go over 1 and up 1, stuff like that. Or you could go back 1 and down 1, back 1 and down 1. But Kyle just told us that there's a problem at -1. Anybody know what this function wants to be for an x value of -1? What is the height supposed to be? It's supposed to be 1. It's supposed to have a height of 1. Instead of an asymptote, we have a gap. And so literally, just draw a hole there. The function looks like the line y equals x plus 2 for the whole graph, except there's just this little gap right there. You might say, what's the point of that? Actually, gaps within graphs are what make calculus possible. There's all sorts of things that divide out in calculus that give us these gaps that are very, very important. Okay? Now, what I'm going to do is show you graphically so you can believe me, because you might say, well, if you graph that on your calculator, there's no way you'd get that. I'll show you. we'll take x squared plus 3x plus 2, and we will divide that by x plus 1. Now, I think this is totally awesome. We'll see if you think the same thing. I'm going to graph in a standard viewing window. Does that look like the graph of x plus 2? Do you see a gap? No, because when you trace it, you don't come out on even integers, do you? But I'm going to zoom as a, remember, decimal. And if I do that, oh, you see it? Is that cool? It's just awesome. Like, look here. If you go to -1, it's like, I don't know what the y value is. And then press it. Oh, the cursor jumps back on. So, I mean, this is legitimately what the graph looks like. That's a real graph that we need to be able to account for. Let's try another one. We got 2 left. Very good. We have -5x plus 10 over x minus 2. What can you, does this factor? And if you factor, does something cancel? Yeah, the x minus 2's cancel. So this graph wants to look like y equals what? -5, but there's a gap at the x value of 2. What would the y value be? At a value of x equals 2, what does the y value want to be? -5. So there's a gap at 2, -5. I used whole earlier because that's what the book uses, but the maturity level of 5th hour wasn't sufficient enough to be able to handle using the word whole. So they couldn't. Yeah, exactly. Yeah, because I would write a whole, a whole. You know. So yeah, exactly. It's like I'm in kindergarten again. All right. Yeah, pretty smart kindergartners. There you go. Get rid of that for YouTube Nation. All right. So here we go. 1, 2, 3, 4, 5. All right. And over 1, 2. So I draw a gap there. And then the line of y equals -5 is a horizontal line the rest of the way, correct? So that's what the graph looks like. And if you drew that on your graphing calculator, you'd get that shape. You good? Okay, so one more problem. I got 6 problems I want you to work on for assignment. This last one, x squared plus x minus 3 over x plus 1. Yeah, well, I'll try to flip to there. So, does this divide evenly? No, you're not going to be able to factor out an x plus 1 and cross it off. So I'm just going to divide it. X plus 1 goes into x squared plus x minus 3. What do you multiply x by to get x squared? No. Synthetic causes problems when you use it in these situations. We're going to refrain from using synthetic division. If you subtract those, what do you get? 0x minus 3. What do you multiply x by to get 0? 0. So 0x minus or plus 0. Subtract. We get that -3 as our remainder. So this is y equals x and minus 3 over x plus 1. So really quick, if you are going to be leaving at 2:45, take out your phone so you could just take a picture of the screen. Okay? Really quick, it wants to look like x, but it blows up at what value? It blows up at -1. And since it didn't divide evenly, it's not going to have a gap. It's going to have an asymptote. I'll show you. Okay, really quick, you can snap a picture, and then we'll finish that problem. That's the assignment. 10, 9, 8, 7, 6, 5, 4, 3. Okay, here we go. So, It wants to look like y equals x. What is the graph of y equals x? It's a line with a slope of 1 that passes through 0. But it blows up, it's a good mathematical term, at what x value? -1 is the problem value. So we have this vertical asymptote. So watch what I'm going to draw. It wants to look like this. But it blows up at that spot. Wait for you to get caught up. You good? Here's where the graph is going to be. It's either going to go like this, start here and curve up, or it's going to start here and curve down. And then it will either start up and curve up, or it will start down and curve up. We don't know which. We can figure it out. This is a value of -1, correct? What is an x value coming from this side that's very close to -1, but not quite -1? Sure, -1.01. We're going to plug in a value really close to there to see, do we get a big value or do we get a really small value? So let's look at our function, x minus 3 over x plus 1. And we're going to take that value that Emma suggested. We're going to plug in -1.01. And we're going to see what we get, if we get a really big value or a really small value. What is -1.01 plus 1? -0.01. So this will be plus, won't it? What is 3 divided by 100th? 300. 3 over 0.01 is 300. So is this going to give us a big value or a small value? A big value. So it's going to start down and it's going to curve up. What is a value really close to -1 from the other side that we could plug in? That's not quite -1. -0.99. So -0.99 minus 3 over, what's -0.99 plus 1? 0.01. What's 3 divided by 0.01? 300. -0.99 minus 300. Is that going to be a very big value or a very small value? Very small. So you can see it's going to start down here and it's going to finish up over there. So it wants to look like y equals x. Now, I know that you guys might say, well, does it really look like that? Can somebody read off the original function for me? X squared plus x minus 3, and it's going to be divided by. Now, look at how accurate of a graph we've got for that, you guys. We'll zoom standard, zoom 6. That's exactly what we have, isn't it? You got to think that's pretty cool. I mean, we just figured that difficult thing out very quickly. Okay? Question. My calculator draws a vertical asymptote, even though it really shouldn't. So different calculators have different settings for that. Here is your assignment. I give you a couple. They follow just like what we've done. Okay? And again, you're not going to have this on your final exam. And there were a few people in the previous hour who said, yeah, I don't really need to do this stuff. Trust me. When you have it on your final exam for second semester, you're going to be glad that you practiced it now. Your brains are no different from anybody else. You need to learn it, try it, and then sleep. That's how you convert to long-term memory. If you're not like that, you're an alien. Okay? Because That's the way the human brain works. You need to practice it, and you need to sleep, and you'll store that information. So practice this. All right.